Okay, good. So thank you so much for coming back after the coffee break. I was a little bit afraid that you won't come back, but I'm good that you come back. So like I always started, I would say that I started with the most important slides of the talk, because with this slide, you have a link that got the whole slide deck. So if you want to check all the code and references afterwards, you have access to that. So this talk is about how to do better testing with PiTest and maybe some other stuff. So if you're interested in testing, I believe that you are a very good developer, because this is something that like we have to care about when we develop, like, write code and stuff. So, whoa, what's going on? Okay. So, I'm Cheuk. So I am an open source contributor. I love contributing to different open source projects. And I also organize a lot of events, because I love being with the community. I go to a lot of events. I see a lot of nice people. I'm very happy. I used to serve in the EuroPython Society board, and I'm so glad that they kind of support my travel this time to be here to see all of you. I'm also the PSF fellow, which means that I contribute a lot to the Python community. You can also contribute a lot to the Python community, and talk to me if you want to know more about how. I'm looking for my next role, so please talk to me if you are an international company and you're hiring. So. Who uses PiTest? Give me a show of hand. Okay, so there's quite a lot of you. So I don't know how much you already know the stuff that I'm going to talk about, but I'm going to talk about it anyway. So if you have used all of these things that I talk about, then you know that you're actually a very good PiTest user. So I always think that what makes PiTest so popular is so popular that people think that's the only way that you can test your Python code. But actually it's not. There's actually a standard library that comes with your C Python. It's called unit test, and as the name suggests, it allows you to write unit tests. And so you don't have to install anything. You just come with Python. Anybody who have downloaded Python can already start using it. So it's kind of like standardized how we write tests in Python. But there's some hiccup there, right? Because PyTest is not, unit test is not the easiest to use, because you have to import the module within the unit test, and then you can, and then with there you build your test and other stuff. So you have to define the class that you test. So it's not as simple as using PyTest. So in another hand, PyTest is quite easy, because all you need to do when you write a test is just to add test underscore in front of when you name your function. So it's kind of very straightforward. You don't have to even import PyTest to run PyTest. Also, another thing that I think that also make PyTest quite popular is that it has some extra feature, which I'm going to talk about today. So these are the PyTest feature that I'm going to talk about, and I want you to count how many are you using, how many you know about already. So first of all, Parameterize. Who have heard about Parameterize? Yes. Ooh, this is a popular one. Yes, I personally also like Parameterize a lot, because sometimes you have been writing tests. Remember maybe when you started using Python, then I have to write tests and stuff. So you're writing tests like this, right? This is maybe someone who is less experienced is going to write a test like that. Okay, I'm going to think of what I have to test and write. Each one of them is a single case, and then maybe some people are doing test-driven development, so they have to write all the tests and then fail it and then pass again. So this is how it will look like when you just write unit tests. However, that sometimes can be very ugly, very fast. If you have a huge application that you're writing a lot of code for, and for each single time when you add a new feature or you found an edge case, you have to write another test. So it becomes super long. You have many test files, and it's kind of very difficult for new contributors to find where are the tests, and how do I have to add a new test, or is it already tested? So all these things are not very open source friendly if you have a lot of contributor and you have a big library. So this is how you can simplify the test by combining a lot of similar test cases together. So for example, this one, as you can see here, before, I have to write 3 tests for these 3 different test cases. And now I can just combine and write only 1 test, okay? And I just put the parameters as inputs from this decorator that's provided by PiTest. So this is how you can simplify your test to make it easier to see what's going on, what you have tested, what you haven't tested. If, for example, you found a new edge case, you don't have to write a new test. You just add a new example here, which is very convenient. But sometimes you may think that, oh, how can I find edge case? It sounds like something very difficult because, for example, if your test involves a lot of users' input, you can't predict what your user is doing, right? They may do something very, very crazy. Or if your user is, we're all Python developers, right? And if they just kind of put in some input that is not like the right type or what it's supposed to be, then it's gonna be tricky. So I would want to introduce you to hypothesis. So hypothesis technically is not something that comes with PyTest. It's another library. I'm cheating a little bit here, but I would like to mention it a little bit so you also know what you can do next step when you want to improve your test. So hypothesis is a library that we call property-based testing. So what is property-based testing? So I have created a chart for you so you can compare how property-based testing is different from what you normally, quotation, because normal is a relative term, what you normally do when you test your code. So I'll just pop all of them up and then just explain a little bit point by point. So for property-based testing, you provide a property of the variable. So for example, you have a variable input. You know it's an integer, but you can't think of what integer the user may input, right? It could be 0, it could be 99, it could be 9,956, So you don't have to find like those cases to test. You just say that, okay, I have this input variable and it's supposed to be an integer. Or if you want to be more specific, it's supposed to be a positive integer because otherwise it's not the right way to do it. So compared to, like I said, normally you have to think of what cases. Property-based testing works really well when you have used typing. I know typing is a very popular thing now in the Python community. People are trying to be more serious with their code, so like we have to make sure that it's in the right type. So with property-based testing is basically like very straightforward because you already know the type of your variable. You just have to use hypothesis to put it there. So hypothesis will find edge case for you automatically. There are some strategy in hypothesis that will try to find something to test for you. Some strategy may kind of randomly pick something and construct them as an input. So so sometimes there are edge cases that we never think of that would happen. So maybe hypothesis can find it out for you because of this way that hypothesis is generating the test case. So hypothesis is very straightforward to use. Use 2 things to put in your test. So decorators, like a parameterize, is a decorator for your test function, right? And then you need some strategy because there's no example input, so all of them are generated by the strategies. So for example, here there's a code. This is using the hypothesis. So hypothesis, we would have decorators here. Ta-da! So this is instead of using parameterize, we use given. So given is kind of a way of telling your testing library that I'm using hypothesis now, and the hypothesis will generate the input here. For example, in the first one, it knows that the test input should be a text. So it will use the text strategy to generate it. The second one is actually more complicated. You can use multiple strategy to construct a more complex example. For example, here I'm generating the task list. So it's kind of a list of things. So it's a list of text. So this is how it got written. So you can combine the strategy to make things. So next is fixture. So who are familiar with fixture? Okay, now there's less people, so we're going like diving deeper. So fixture is, so what is a fixture? For those of you who haven't put their hands up. So Fixture is actually let you to combine some element that got reused into a separate place. The idea is, because we're writing unit tests, we want to minimize the variables in each test as much as possible. Because if that specific test fail, you don't know if it's a very big unit test, like big test. If something fails, then it could be means a lot of things can go wrong. You don't have a very clear point that which part of your code is broken, what was the problem. Like the entry point would be very difficult to find. So that's why we want to make your unit tests as concise and as small as possible. So with fixture, you can take all these elements that is not involved in your test, that's not what you are trying to test. You can put them in a fixture. So, so supposedly those fixtures are fixed. Once you have written it, you don't change it, for example. Then when your test fails, then you know it's not something to do with fixture, it's something that you're testing. That's like something in your code that is wrong. So you have to fix those. Another thing, like I said, you can reuse the element. You will see in the example in a little bit. I'm not going to give you the answer here immediately. And also, you can make the fixture super complicated. I will explain again like later in more slides. And actually, it enables you to build a plugin for example, PiTest. Like you can, because PiTest come with a lot of things that are useful, but there's also more specific thing that PiTest doesn't provide. And then there are people who build like plugin libraries to work together with PiTest and test specific things. And a lot of those libraries are actually using fixture to add in new features. And they can distribute the fixture to someone else, for example, you, to use it. So this is an example, very oversimplified example of using fixture. This was our test, right, using Parameterize. It's all good, but now I have another test. And then in both tests, I would have this task list that I'm using as an example to test. So this time I'm not generating it from hypothesis, I'm just giving a fixed example. So I don't want to maintain the both of them in two different tests. What if like I decided to change one and then but I want to keep it consistent throughout all my tests because, for reasons. Then you can put it as a fixture like that, separate it from your test. So this is oversimplified case. You may think, oh, it's not very useful, but imagine if it's a database here, right, instead of a list. It's a database that you want it to be, persistent because you want to test again the same state of the database. Then you want to make it a fixture and put it aside like this. So yeah, then after that you can just call that in the task list as if it's something that got input, and then you can use it. So fixture, like I said, it can be shared. It's not necessarily need to be in the same file. For example, this is an example from the documentation page. What it does is that it have a conf test.py, which store the configuration for all your tests. You can define your fixture there, and then it will get shared between different test files. For example, I have another test file that's called test module, and now I can use it as if it's already there. So this is the magic of PyTest that you can do with the fixture. So like I said, fixture can be very complicated. You can define a different scope of how the fixture can be shared. It can be something like you share among a class, but outside of it, then the fixture is not shared. Modules, packages, or just that section, right? It will leave. So for example, again, the example of the database, right? You want to test against a database. You spin up a database in, for example, a Docker container. You want that database to stay in the same stage until your whole test is finished. So the section of testing is finished. So then you can also do it like that with a fixture that is that stay there forever until it's end, and it will you have to write some code to tear it down. So this is from I pulled it from the documentation. This is a picture of showing how you can create different fixture within different scope and stuff. Every time I look at it, it gives me a nightmare. I was like, what am I looking? Oh, my brain hurts. So I'm not going to dive into it. What I'm going to do is to point you to the place that you can learn more about it. So fixture, in my opinion, is like one of the most powerful feature in PyTest. And if you can master it, you can say that you are a power PyTest user. And also you can maybe try writing some third-party plugin for PyTest, which you can, publish your own library, then it will be very cool, So yeah, please, if you're interested, read the documentation, and they explain it very, very well in detail. So, but I don't have an hour, so I'm not going to explain it. So this is the homework for you. So now go into the territory that is. I would say that it's like a wicked magic kind of category. Who have used mark_exFail before? So some of you, yeah, this one, there's a reason why it's not many of you have used it, because like I said, this is kind of like a wicked magic. So imagine now you're a dev, kind of create a new feature. And this, because your product or the library or whatever that you're creating, it supports multi-version of Python. And now you want to create a new feature just for example, the newest version like 3.12, when it comes out, it only works for 3.12, right? Because 3.12 is very cool, and you write this feature just for 3.12. But then now if you run the test, right? If you run it against like 3.11, 3.10, 3.9, well, they will all fail. So what you gotta do, because if you run the test, then your whole test suite will fail, right? Your CI will be broken. If you run a GitHub action, you see that big cross that is really like screaming at you. You can't deploy your work. So yeah, you know they will fail. You don't want to fail all of them. You, like maybe in your pipeline, you test it against multiple versions of Python. You only want to run this test on 3.12. So you can actually do something about it, right? It's kind of, you can kind of specify that, oh, I only want to run this test against certain conditions, not just like version of Python, maybe some OS system or something like that. So, yeah, I want to skip a test gracefully. I want to, tell not just PyTest, but maybe the developers who come in later that, I'm skipping this because I know what's going on. So. Mark skip is designed for that, that you can let you skip a test. So it won't be failed. So if you try using it, it will just give you I think instead of the green dot or a big red F, which is fail, you have a yellow S, which means that it has been skipped. Or, for example, like the situation that I mentioned before, if you have a certain feature that only supports certain condition, then you want to run the test, then you can specify those conditions with skip if. So, for example, here, the feature is for 3.12, nobody's using 3.12, well, most of the people are not using 3.12. So, yeah, coming soon. It's not there yet. I will skip it. The CI will still run. It will still be there for a while until it's really useful. Or you can just, specify a certain Python version for that. So, you can see that actually here, there is a, did you find a typo or something? No? Okay. So you can find like, there is actually a reason you can put it there to say like, oh, why you skip it, right? And I would say that the reason is very important. I would look back to that point later. Another thing that is very similar to skip or skip if is to mark exFail. Again, like it's something that if it's failed, we should not worry about it right now. The CI, should still be running. You should still deploy whatever that you should deploy. But this is fixed later, right? You're Friday. At like I don't know, we want to go home and okay, mark exFail, and then I'll come back on Monday to fix it. Okay. So, but you see that this example here, I try to always put the reason, like why you skip it, why it marks exFail, why is it like that? Yeah, please state the reason. Like I said, this is very dangerous. This is like your colleague may try to kill you if you just like, you can skip everything, right? You can just, you can mark exFail, like everything. It's fine. You can still deploy a half-broken module, whatever, like that. That's still fine. But please state the reason why you do that, because, even like, not just for comedic reason that, oh, I just want to, whatever, but for example, someone is picking it up, right? For example, like Friday, okay, you mark it expel or, but then like you have a holiday. Nobody's, you are not coming to pick it up again on Monday. So your colleague is going to pick it up and fix it. So you have to state the reason and make sure you communicate with other developers that, okay, this is what happened. That's why it's failed now. We should not worry about it, but please fix it when we are ready. So here are the top tips. I'm going to recap what's going on here. So Parameterize lets you combine all these different tests that looks, very similar, but with different variables. You can make them more organized and easy to maintain, easy to read, to combine them with Parameterize. Fixture is a very useful feature in PyTest. It makes you write a more concise and precise unit test. And also you can share the feature with other people as well if you're a very advanced user. Max exfil, very, very dangerous thing, but it may save your life, so you can still, go out and party on Friday or things like that. So, yeah, but use it carefully. So that's the end of my talk, actually. So, EuroPython, I want to tell you about EuroPython. So EuroPython this year is happening in Prague in July. Like I said, EuroPython Society, who is the organizer of EuroPython, is very kind to support my travel here to run the Humble Data workshop a few days ago for the local community here with PyLadies. So thank you for them, and if you can't make it, I know it's very close and the flight ticket may be very expensive at the moment, but maybe next year try to come and join the EuroPython, because the community in Europe would love to see all of you. So that's it from my talk, and thank you so much.